Okay, another quick one, just going over Pythagoras and trig ratios. Okay, again, things that we should kind of know from junior cert. So looking at Pythagoras, as we should kind of remember, this is your right angle triangle. You can only use Pythagoras with a right angle triangle. And the rule that we have, and we see in our log tables, is that a squared plus b squared is equal to c squared, where c is the side that we call the hypotenuse. So sometimes we write out that rule with h squared instead of c. So applying it to the one that we have here, we would have 4 squared plus 3 squared is equal to c squared. 16 plus 9 equals c squared. 25 is c squared, which means that c is equal to 5. So again, Pythagoras should be fairly straightforward at this point. What we should remember as well from junior cert is your 3 trig ratios. So we can use these ratios to find missing sides or missing angles of a right angle triangle. And that's important to remember as well. They can only be used on right angle triangles. And the way we remember them is this kind of mnemonic, if you have it here, SOHCAHTOA. Okay, so let me just make that clear as well, because that does not look like a H. SOHCAHTOA. So it just means that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. And again, these ratios are in your log tables, not with these words of opposite and hypotenuse, but labelled with letters. So it is a way, if you've just forgotten, if you blank on the day, if you blank when you're doing questions, you can check it in there as well to make sure you're using kind of the right sides with each one. So if we're given an angle, say sine of 35, we can just use our calculator. So we press sine 35 and we get our answer. Okay, so fairly straightforward. And again, as we've kind of said, making sure our calculator is in the right mode, and sine of 35, and we get our answer then. What we have to remember as well is 1 degree is the same as 60 minutes. So the same as we kind of have with hours. So, and we've minutes and we've seconds as well. So if we're using our calculator and we want to find, for example, 34.5 degrees is the same as 34 degrees and 30 minutes, like half an hour. So if we're finding sine of 34.5, we can find sine 34.5, or we could get sine of 34 degrees 30 minutes. Okay, using the button on our calculator, and it looks like this here on your calculator. Okay, so it looks kind of like this here. And what you need to do is, after you type in 34, you would press that button, and after you type 30, you would press the button again, and that will kind of compute it as 34 degrees 30 minutes. Okay, generally you'll see just 34.5 degrees is what you're more likely to be working with, but just it's worth knowing that there are 30 minutes in a degree and 60 minutes in a degree, 60 seconds in a minute, and that kind of thing. It's the same as time. Finding an unknown angle. So to find an unknown angle, we use our trig ratios. So for example, if sine of A is 0.8661, then to find A, I use the sine inverse on my calculator. So sine with the -1, and we get that A is 60 degrees. Okay, again, I'm flying through this, I suppose, and they should be things that are familiar to you. So this should all be kind of a recap of that. Looking then at angles like 30 degrees, 45 degrees, 60 degrees, these are angles that come up a lot and are used a lot in questions, and their ratios are in your log tables in the formula and tables book. And with those type of ratios, particularly that have specific answers, we can use triangles to represent them, and that can help us find other ratios without calculating the angle. So sometimes in questions we don't want to work out what the angle is, but we want to be able to just rewrite the ratios. So for example here, if I'm given sine of A, we have to think first, well, what is sine? And we've said that for a right angle triangle, sine is opposite over hypotenuse. So if I were to sketch a triangle, okay, maybe a better one than that. If I were to sketch a triangle where this is going to be my angle A, this would be my opposite, this would be my hypotenuse, this would be my adjacent, and I can fill in the numbers. So my opposite's going to be 1, my hypotenuse is √2. Now to find my adjacent, I can use Pythagoras. So √2 squared is 1 squared plus adjacent squared. So 2 is 1 plus adjacent, which makes my adjacent squared. My adjacent squared is 1, which means my adjacent side is also 1. Okay, so I get that my adjacent side is 1, and from that, and let me just move this down a little bit, from that I can write out, well, that means that cos of A is 1 over root 2, and tan of A, which is opposite over adjacent, would be 1 over 1. Okay, or just 1. And what that means is it just lets us rewrite those ratios without having to actually work out what that angle is. Sometimes that can be really, really useful for some questions to quickly kind of find another ratio. So same thing goes here. If tan B is root 5 over 2, find the value of sine and cosine. Well, we can kind of sketch our triangle. This can be B here. Tan is opposite over adjacent. So we need to find my hypotenuse. My hypotenuse is going to be my root 5 squared plus my 2 squared. So 5 plus 4, h squared is equal to 9, which means h is equal to 3. And that means, of course, then that sine of b is going to be root 5 over 3, and cosine of b is going to be 2 over 3. Okay, so you can see that it's fairly straightforward. The key thing really is sketching those triangles. So sketch your triangle, fill in the sides where they're supposed to be based on the ratio, and then a lot of the time you'll just be using Pythagoras then to work out the missing side that you'll need. It's usually, just be one that you'll need to work out. Okay, so quick speed run of this anyway, but let's look at an exam question. Okay, so generally these ratios and Pythagoras and these will come up as part of bigger questions more than they would come up in their own question. So they'll come up as part of your 3D problems, as part of a question with a cosine rule or with a sine rule or finding areas or things like that. So it is important to be able to do them, but they generally will be part of a bigger question. But let's look at this one here. So the triangle XYZ is right angled at X and XP is perpendicular to YZ. So we have a few right angles going on. They give us a few sides. They're asking us to find the value of K. So we can see that we have one right angle triangle here, which is YXP, and we have one of the sides. We don't have the other side, but we have that K is part of that one. We have another right angle triangle here, which is XPZ. And again, we have two of the sides there that we could use for that one. And then lastly, we actually have another right angle triangle as well, and that is the whole outside triangle, so XYZ. And for that one, we have one side, which is the hypotenuse. Okay, so we have the hypotenuse for that. So what we could do here, what we can do here is maybe take these separately. So take them one at a time. So let's focus on XPZ first. So XPZ. We have 8 here, we have K here. And what we're going to do is we're going to look for this side here, XZ. We're going to try and rewrite this side. So we know that XZ, because it's a right angle triangle, it's equal to K squared plus 8 squared. Okay, so XZ squared is K squared plus 8 squared, which is K squared plus 64. And what we'll do is we'll just leave that as it is. Okay, I know we have it squared, but that's okay. We're just going to leave it like that for a minute. We're going to do the same with the yellow triangle here. Okay, and we're going to look for this side now, XY. So I'm looking in each triangle, I'm looking for the side that I don't know. So XY is equal to XY squared is again K squared plus 4 squared. So XY squared is K squared plus 16, sorry. Okay, again, perfect. So we leave it squared for the minute. Now, lastly, what we're going to look at is going to be the green triangle here. Now, bad sketch of it, so let's try it again. Okay, so we're going to look at this green triangle here. And what we should notice about the green triangle is that this side is the one that I've highlighted in yellow. This side is the one that I've highlighted in blue. Okay, because this is X, this is Y, and this is Z. And then we have this side in green. And the side in green here is actually 4 plus 8. So it has a total of 12. We also know that this is a right angle. So 12 squared is equal to XY squared plus xz squared. Now we should be able to see why I've left those squared in the previous part, because I could kind of see that this was where we were headed using Pythagoras again, so it was easier to just leave them in that form than actually writing them as square roots. So I'm taking the answers from the first two triangles I just looked at, and we found those two sides, so we're just rewriting those. 12 squared is 144, and we'll keep going then. So 144k squared plus 16 plus k squared plus 64, and we're just tidying up as best we can. So 2k squared plus 80, okay, 2k squared minus, let's see, so 80 minus 144, so minus 64 is equal to 0. Okay, so 2k squared minus 64 is equal to 0. Okay, so let's follow this one through as best we can. So let's maybe divide by 2 here. Okay, so k squared minus 64 divided by 2, of course, is 32. 32 is equal to 0. Okay, and continuing then, so k squared minus 32 is equal to 0, which we can say then k is equal to, k squared is equal to 32, and k is equal to, well, we would say plus or minus root 32. Now in this case, the answer obviously can't be minus 32, so k is just going to be root 32. And we've been asked to give, just to find the value of k. Just to find the value of k, so we can take our answer, we can find the square root, and we maybe break it down as far as we can, and we'll give our answer as 4 root 2 centimeters, I think it was. Or, no, we're not actually given any units, so we just leave it as is. So we get our answer being k is equal to 4 root 2. So we can see they're working that one out. We're following it through with the answers that we've been given. So we're following through with the k squared and the 4, and the 4 squared, the 16, which gave us xy, finding xz the same way, so the 8 squared, and again our k squared is part of that one, and then using that then in the last part, so adding our 4 and our 8 then to get our hypotenuse for our bigger triangle, and then using that in order to answer the rest of it then, working it out that way, okay, by combining our answers from the previous part. And it's just a matter then of following it through and working through the rest of it then to work out exactly what k would be. So you can see they're important to just make sure you're happy with all those ratios, that you're happy with Pythagoras, because as we've said, those will come up as smaller parts in bigger questions, but you need to be able to do those earlier parts because they're kind of taken as known and well understood from your junior cycle work. So it's important that they are kind of well understood and that you're confident using them.